Hi all, this video is intended to help with problems 14 and 20 on the Achieve section 3.9. These were some good questions here. The first one, it gives you an exponential function base 9 to the 2x, and it asks for a tangent line through x equals 1. Now your problem's probably slightly different, but similar. So in this case, if I needed a tangent line at x equals 1, then I first had to find the point. So you'll see all I did is I plugged 1 into the original function, and I just get 9 to the second power, which I know is 81. Therefore, my point that this tangent line goes through is the ordered pair 181. Now I need to try to find the slope. Before I can find the slope, I need to take the derivative. We know the derivative of any exponential function is that exponential function times the derivative of its exponent times the natural log of its base. So now once I get the derivative formula there, I just need to evaluate that derivative at 1. And as soon as I do that, I see it's just going to be, again, 9 to the second power, but then I have times 2 natural log of 9. I went ahead and said 9 to the second is 81 times 2 is 162. So the slope is 162 natural log of 9. I took that slope along with a point, plugged it into my point slope formula. So the y minus y1 became y minus 81. The slope, 162 natural log of 9 times x minus x1, which was just a 1. Now, the format that Achieve is going to want for these problems that have the irrational answers, rather than taking that irrational slope and distributing it through there and getting a decimal, they want you to just leave it like this and move the 81 over. I think they'll accept other answers if you distribute, but this is what they're really looking for. If you just leave it like that, move the 81 over, that's the equation of your tangent line. Now the next one is a problem that it's asking us to use logarithmic differentiation. So the first step in this one, I have to take the natural log of both sides to comply with the goal of the problem, logarithmic differentiation. You'll notice when I took the natural log of the left-hand side, I went ahead and expanded with my logarithmic principles on the right. I knew I would have 3 separate logarithmic functions. The 2 in the numerator would be added, the 1 in the denominator subtracted. So I get the natural log of x plus the 3 came down in front of this one, 3 natural log of x plus 3, minus 2, the second power came down in front of that log, of 5x minus 1. Now I took the derivative. Derivative of the natural log of y is 1 over y dy dx. Derivative of the natural log of x, 1 over x. I knew that the 3 would get carried along with the derivative of the natural log of x plus 3, so I had 3 over x plus 3. Technically, you'd say times the derivative of x plus 3, but that's just a 1. Minus 2, and derivative of the natural log of 5x minus 1, put that 5x minus 1 in the denominator. And then I needed to multiply by the derivative of 5x minus 1, which is where that 5 comes from. Please don't forget the chain rule. The only natural log that the chain rule affected here was the last one, because the derivative of the inside of both of my other ones was just a 1. Now I come down and I can say, well, okay, dy dx is equal to y, which is nothing more than your original function, times this expression simplified out. Okay, but now they're going to want us to algebraically simplify. I think myself, I would have actually been happy with that answer, but Achieve is wanting you to keep on working. So what they're wanting you to do is take the algebraic expression that we got from the derivative of those logarithms, get a common denominator. So I know that the common denominator had to be x, x plus 3, and 5x minus 1. I put all of those down there. Where did this first term come from? Well, in order to get that common denominator in the first term, you'd have to multiply by 1 by the other 2 denominators, which is x plus 3 and 5x minus 1. Notice that's the product I have there. The second term needed to be multiplied by x and 5x minus 1 in order to obtain the common denominator. That's why I've multiplied those there. And then the last one, you already had the 5x minus 1 in its denominator. It needed an x and an x plus 3, so I had to multiply the numerator by x and x plus 3 as well. So now I have my common denominator and my simplified numerator. Now all I need to do is multiply out those products and combine like terms. So I multiplied here in the next step. I said if I FOIL out this first group, x times 5x is 5x squared. Then I would have minus x plus 15x for plus 14x. 3 times negative 1 minus 3. My next term, I would have 3x times the group 5x minus 1, which gives me 15x squared minus 3x. Then I have negative 10x times x for minus 10x squared. Negative 10x times 3 minus 30x. From this step to the next, I put my final answer, and I knew I could do that because look what happens. This x and this x plus 3, this x cancels with the factor of x in the numerator. This x plus 3 cancels with one of the powers of x plus 3 in the numerator. That's why I have an x plus 3 squared in the numerator. The 5x minus 1 multiplies the 5x minus 1 squared to give me 5x minus 1 to the third power in the denominator. And then it's just a matter of simplifying this expression. I collected like terms. 5x squared plus 15x squared is 20x squared minus 10x squared for 10x squared. The x terms, you had 14x minus 3x, that's 11x. 11x minus 30x for minus 19x. And then the only constant in the entire problem was 3. We have our fully factored final fantastic form of that answer. That's an excellent question. I really like that one.